This will give us a much more complete picture of the world we know thanks to its solid parts. From this moment on, thanks to the James Webb Telescope, the magnificent picture can be seen everywhere. Join us to discover the James Webb Telescope and how it can change everything. Learn how it all began in 1996, when the idea of a telescope was first proposed. Experts and engineers from 3 groups, public and private, came together to see if NASA could actually build a telescope. All 3 groups came together with the same goal, to build a telescope. In 1997, NASA decided to pay for additional testing to meet more specific and expensive requirements. In 2002, the Telescope Manufacturing Association selected a team to build the telescope's most important instruments and an advisory committee of experts to support the construction cycle. The telescope was originally named the James Webb Space Telescope, after a former NASA administrator who had made many contributions to the program's creation that same year. When engineers and scientists began assembling the Webb telescope in 2004, they knew they had to invent new technologies and techniques to meet the mission's critical scientific needs. While space researchers can work on Hubble to fix and improve it, Webb must work far away from Earth. Despite these challenges, the team completed all 18 parts of the reflector mirror and ran rigorous tests to make sure the code was right. It is now possible to imagine the telescope finally going into space and doing its job. The James Webb Space Telescope was built and operated from 2012 to 2013. Most of the telescope was built in various locations around the world. Work began on Webb's UV protection layer in 2013. This layer protects the telescope from excessive forces and allows it to function properly in space. Over the next few years, Webb's unique scientific equipment was subjected to extremely rigorous testing, including shaking and high temperatures. 18 different mirrors were carefully installed on the back panel. Meanwhile, Johnson Space Center in Houston, Texas, received and tested the components. The telescope and its equipment underwent final environmental testing in a massive thermal vacuum chamber in 2017 to ensure they would function properly when sent into space. Webb was finally sent into space around Earth on December 25, 2021, at 7:20 a.m. Eastern Standard Time. How does the camera actually work? People often make space travel seem simpler than it really is. So when you first hear about it, it might seem like just another camera. Actually, it wasn't. It was so unexpected that it took so long to get the idea off the ground. The James Webb Telescope, a large telescope, was built to see things in the universe that other telescopes can't see because they're too cold or dim. These are things that are just starting to form, like planets, galaxies, and stars. The telescope is designed to capture infrared light, which distant objects use to radiate most of their heat. Thanks to this, we can learn more about these things. Infrared cannot pass through gas and dust, so we see them as blurry. Webb, on the other hand, can see not only visible light and infrared but also ultraviolet light. This allows us to take pictures of objects hidden by gas and dust, giving us a better view of what is happening far away in space. Infrared can also be used to focus on features of objects on Earth, such as their chemical properties or temperature. Infrared is important to many areas of science and progress. It helps us understand how stars, planets, and other celestial bodies are formed and how they change over time. It can also be used to look for signs of chemical contamination in the air. The telescope is equipped with a variety of imaging and spectroscopy instruments, as well as an advanced thermal management system that can operate in harsh environments such as space. This is very important because these cameras have to go into space on their own and process everything there without outside help. The telescope was launched into space and detached from the launch vehicle. It then turned around and began its long and arduous journey toward its target. There were several important moments during this cycle, such as the transit of the moon and its disintegration into several parts. When everything was ready, the telescope was one of the most useful instruments of its kind. Let's take a look at the steps this very important camera took to get into space. Before we talk about why this is so important, the first thing that had to be done was to assemble the solar panels. This was done after the rocket launched on the third day of the trip. While the shuttle was still in the hull, two very special beds were installed. These bags were used to store Webb's essential sunscreen. The cameras are kept cool through these screens so they can operate directly in space. It was very important to place these shields correctly so that the camera could function properly during the trip. The tower with the tool package was moved to its final location and assembled in 4 days. The process involved many complex steps, but the way the telescope was assembled made everything happen quickly. The stress of the sun increases the velocity overlap, creating a force that keeps the camera stable. Then the solar control layer is installed, revealing a tennis court-sized UV blocker. The sunshade and the middle pull plate are all installed and shipped. Then the 5 parts of the sunshield are separated. But that's not the end. Before the James Webb Telescope could be sent into space, several important steps had to be taken. On the 10th day, the second mirror and the frame that holds the smaller mirror in place were installed. Then, on the 13th day, the wings of the primary mirror were unfurled, completing the telescope's final form. Once all this work was done, the telescope was ready to begin its mission of searching for distant stars and planets. The interesting thing about the James Webb Telescope is that it wasn't designed to do just one thing. It had to do a variety of tasks. Going back in time will help us learn more about this telescope. The James Webb Space Telescope can be used by cosmologists like Daniel Einstein of the Harvard-Smithsonian Center for Astrophysics to observe the process by which galaxies began to form. Distant galaxies appear older than they actually are because light travels so fast. The telescope can study galaxies' early past to learn how they formed and how they changed over time. For example, by observing different galaxies at different stages of growth, Einstein was able to get a complete picture of how galaxies formed and changed over time. Webb is great for studying distant galaxies because it can see infrared light. As the universe expands, the light from these galaxies gets longer over time. This changes the wavelength of the light from visible or ultraviolet light to infrared. Because Webb is so big and cool, it can see much farther into space than other telescopes and is excellent at capturing infrared signals. This way, it can observe how galaxies change over time and take pictures of those changes. Webb allows us to study how galaxies form and change over time, helping us learn more about the universe. Scientists can study how stars form. These thick clouds of gas and dust are where stars are born. They are called stellar nurseries. Scientists cannot study these regions using conventional optical equipment because the clouds are so thick that visible light cannot pass through them. Infrared, on the other hand, can penetrate dust clouds better than visible light. This will allow scientists to probe deeper into the core of star-forming regions than any other instrument. Because the Webb telescope can see infrared, researchers will be able to learn much more about these places than ever before. Maria, a space infrared expert at the University of Arizona, is in charge of one of Webb's cameras. She says that red light has a longer range than blue light, so it can pass through dust in the air better. Infrared light can pass through dusty spaces better than visible light. This is why the sun appears redder at night than during the day. Hubble was able to see stars moving across the surface because Webb could see infrared better. Webb's wider infrared range will help scientists peer deeper into the dust and learn more about how stars are born and grow. Black holes are one of the most mysterious entities in the world because they trap light, making them difficult to study. But we can see how they change the galaxies and stars around them. Researchers have studied many aspects of black holes using telescopes such as X-ray telescopes. For example, they have studied how large disruptions in nearby stars heat and energize the region around a black hole. NASA's Webb Space Telescope will be able to see infrared light, which will help scientists learn more about black holes. By peering into the cooler gas and stars moving around a black hole, scientists can learn more about these strange objects and the complex physics that occur nearby. While black holes cannot be seen directly, scientists are still studying them, and they will remain an important area of research for a long time to come. When looking at a star in a thick, dusty part of space, it can be difficult to see exoplanets. That's where the Webb telescope comes in. These problems are too big for optical telescopes like the Hubble Space Telescope to handle. The beauty of Webb is that it can capture light from stars even when they're blocked by dust clouds. This can help us learn more about the atmospheres and features of these planets. Researchers have begun to study how atmospheres form on exoplanets. Webb has made great strides in planetary research and the search for new planets. The telescope has already made a major contribution to space exploration. The Webb telescope is not just one of the best telescopes in the world. It is also important in many other areas. Thanks to the Webb telescope, scientists can learn more about how the universe formed and where we came from. The telescope can detect life on exoplanets, study how their atmospheres work, and even find out how they produce energy. This will help scientists build a more complete picture of the universe and learn how stars and galaxies form and evolve. The Webb telescope will give scientists many new tools to study the universe. It will help us see what's hidden and learn more about how galaxies form and grow. The James Webb Telescope is truly something special in the world of science and discovery.